For recording purposes, today is trigonometry. I'm mainly dealing with right angle triangles. Sine, tan, and cosine are the formulas we're going to be experimenting with today. So before we get started, right, we have a little game to play, right? What's going to happen here is that I want you all to choose one character, and one by one, the characters will perish throughout the game. Only one character will survive, right? The gist of the story is that there's a mad scientist and he's freezing animals to death. Only one will be alive. So let me know on the chat which one is your pick. So these here are the most popular calculators. It's either most likely you're going to have a Sharp or a Casio, right? Now, even if you have a slightly different calculator, you might have similar buttons on it. The first thing you have to do is make sure at the top of your calculator, whether it's a Sharp or a Casio, it doesn't really matter. Make sure at the top of the calculator, it either has well, I'll write it here, the letter D or D, E, G. The same thing goes over here. Make sure it either have D or D, E, G. If you have R or RAD or G GRAD, your calculator is on the wrong mode. Right now, I'm not going to be, usually on these calculators, the mode buttons will allow you to change different things on the calculator. Also, if you don't know how to change it, somewhere on your calculator, it might be behind your calculator or in front, there's going to be a small button you can press, a little pinhole button that you can use a pen tip to press, right? But remember, everybody has such different calculators. I'm only going to be able to do so much online, okay? So make sure you see D or DEG. If it's on R or GRAD, my advice is to reset the calculator. Look for the reset button. Today's topic is going to be dealing with three buttons. The sine button, right? There's three buttons. The sine button, the cosine button, and the tan button, right? On both calculators here, you will see I'm underlining it, sine, cosine, and tan. They're very easy to spot. And on the Casio calculators, they're very easy to spot too. Sine, cosine, and tan, right? So I'm underlining it here. Now, in sine, tan, and cosine were basically created for angles, like 30 degrees, 40 degrees, so you could sine an angle, cosine an angle, or even tan an angle. Now, if you know, just play around with it, right? If you press the sine button, obviously what will be written on your screen? If you press sine button, you will see sine written on the screen, obviously. The same thing for the Casio. Now, what we need to know, right, is that everything in maths has something to be the opposite, okay? Like the opposite of a positive is what? Negative. The opposite of a multiply is what? Divide. Well, guess what? The opposite, there are opposites of sine, tan, and cosine. So the opposite, I'll write the word opposite here, right? OPP, well, let's spell it out one time. The opposite of sine is sine with a small -1. This -1 stands for the word inverse. So the opposite of sine is sine inverse. The opposite of cosine is cosine inverse, a cosine with a little -1 hovering above it. And the opposite of tan is tan inverse. Some people say tan -1 or cosine -1, but the real word is sine inverse. Now, how do you get the inverse of sine, cosine, and tan on your calculator? Now, if you press the sine button, you will get regular boring sine. If you press cosine, you're going to get regular boring what? Cosine. To get the opposite on the sharp calculators, you have to press the second function button. I got pink here. You have to press second function and then the sine button. If you press second function and then the sine button, you will see sine minus 1 appear. On the Casio calculators, you have to press the shift button and then the sine, or the shift button and then the cosine. So on the sharp calculators, the second function button gives you the opposite, and on the Casio calculators, the shift button gives you the opposite. Just try it now. Press second function sine and see if sine minus 1 appears on the screen. On the Casio calculators, press shift and sine and see if you see sine minus 1 or sine opposite, right? Like I said, I know there are many different brands of calculators out there, but there's only so much I could have prepared for, right? I know that's a lot to take in there, right? But don't worry, I'm going to try to make today as, how you say, as easy and easygoing as possible. Now, here's a good idea. You see, when you're dealing with trigonometry, sine, tan, and cosine questions, oh, by the way, there are many different types of triangles. We all know this from primary school. It have equilateral triangles, scalene triangles, right angle triangles. Everything today only deals with one type of triangle. And guess what kind of triangle that is? A right angle triangle. These formulas, everything you see here today, will only work for right angle triangles. And I know what you all are saying, but suppose in the exam, we don't get a right angle triangle. How do we do those types of questions? Well, for triangles that are not right angle triangles, they have a different set of formulas, which will be discussed for, only with the Form 4s and Form 5s and adults in the Tuesday class. So I just want some practice here on the calculator. My advice is that when we're doing sine, tan, and cosine, as usual, we always round off properly to how much decimal places? 2 decimal places. So just to make sure everyone is okay. I want you all to find the value of cosine 35 degrees. Or you don't have to press the degree sign on a calculator. You're pressing the normal cosine button. This is regular, boring cosine. Just press cosine, type in 35 and press equal. And round off the value to 2 decimal places for me, right? Remember, your calculator has to be on D or DEG mode, right? Press cosine 35 and make sure you are seeing this to 2 decimal places. 0.82. Then you do not put a degree sign by the answer. It's just 0.82. No, the answer is just 0.82, not cosine 0.82. You're just writing the value on the screen, okay? Try sine 20. This is regular boring sine. Press the sine button, SIN, type in 20 right after, just press equal. And you're going to be seeing 0.34. Easy stuff here, guys. This is just to make sure your calculator's on the correct mode and it doesn't freak you out, okay? And try the last one for me. Tan 45. Press tan, regular, boring tan, 45, and you're supposed to see exactly 1 on your calculator. Okay? Great. So that's standard. But remember, I told you all that sine, tan, and cosine has opposites, right? You'll remember in regular boring maths, right? Like if I ask you to solve for x and I tell you you had 4 plus x is equal to 7. If you wanted to solve for x and you all would throw across positive 4, and when you throw across positive 4, you get the opposite of 4, minus 4. I think that's something we covered a long time ago. The point is, in maths, whenever you're trying to solve for a letter, you most likely need to throw something on the other side. So I want you all to look at all the questions on the right-hand side, okay? Let's erase this to make everything look a little bit better, right? Right. So if I ask you to solve for P, so let's say the aim of the question is to solve for P. Doesn't that mean you want to solve, number P represents an angle because cosine, sine, and tan were made for angles. So let me rephrase that question. We want to solve for angle P. So that means if we want to solve for angle P, we need to take cosine and throw it across. But in maths, when we throw something across, don't we get the opposite? A few minutes ago, sorry, I showed you what was the opposite of cosine. So P remains on this side, and when you throw across cosine, the opposite of cosine is cos inverse. And who's weighted on this side? 0.45. Could you all type in this on the calculator? Press shift or second function cosine. That will give you the opposite of cosine, which is cosine with a little minus 1. And then type in 0.45 and press equal. Second function cosine and then type in 0.45. In other words, the opposite of cosine, and immediately after type in 0.45. Rounded off to 2 decimal places. I see some people going to the nearest whole number. Your teacher will not like that at all, right? Second function, cosine 0.45, and I'm seeing this on my calculator. 63.26 to 2 decimal places. And yes, you have to put the degrees here because we are solving for angle P, and angles are measured in degrees. Let's try the second one together. In the second question, we want to solve for A. We want to solve for angle A. So that means we have to get rid of who? Mr. Sine. Throw across sine. And what's the opposite of sine again? The opposite of sine is sine inverse. And you know how to type in that on a calculator. You press the second function button or shift button and then sine. And who are we sine inversing? Who's waiting on that side? 0.55. Type it in and let me know what you get for angle A. And I'm seeing 33.37 if we go properly to 2 decimal places, right? Right. Right. So we're going to throw across tan, and the opposite of tan is tan inverse 0.5, right? Let's see what we get here. Second function, tan 0.5 is 26.57 degrees. Right. So I think you all deserve a little small break there. Let's see who's the first character to go. So let's see who's next here. Who's the first to go? The first character to go is, oh no, it's Omar the octopus. Anybody's out of the game? Omar is out. I think a lot of people are out of the game. There were 2 octopus, right? One called Omar and one called Otis. Omar from Barbados is gone. right? Great. Let's go. Right. So let's talk about right angle triangles. Now, everyone is supposed to have a little idea about right angle triangles. We did Pythagoras theorem last term, and I explained that right angle triangles have something called what? A hypotenuse. How do you know which side is the hypotenuse of a right angle triangle? Well, here we have a situation with a brick wall, a wooden fence, and a grass lawn. Obviously, the three sides come together to form a right angle triangle. I think we can all agree, right, that over here is the right angle. Okay? And from last term, I spent a lot of time explaining that what? Opposite the right angle is what? The height or the, oh God, I can't spell hypotenuse here. I'm just going to spell, I'm just going to put HYP. Opposite the right angle is always what? The hypotenuse. So even in this triangle here, here's the right angle. Opposite the right angle is the hypotenuse. So in both diagrams, the grass, that side, is the hypotenuse. However, when we're doing sine, tan, and cosine, you're going to be hearing three terms. Hypotenuse, I mentioned him already, but you're going to be hearing about Mr. Opposite and Mr. Adjacent. A lot of people have problems identifying the opposite and adjacent. Nobody really has any problems identifying who? The hypotenuse. Now, when you go in your textbooks, right, they're not going to write HYP for your hypotenuse. They're going to write the letter H, which makes sense. Let me explain how to find the opposite and adjacent. Here's what a lot of people don't know. Opposite and adjacent all depends on where you are standing in the triangle. So I want everyone to imagine they're standing by this red car. The red car is obviously an angle. It represents an angle. In any right angle triangle, I don't care what the examiner do, you make sure and put a H by the hypotenuse first. Always. There are two sides left. The board, the wicket, the fence, the board fence, and the wall. If I am standing by the red car, isn't the wooden fence the opposite side, opposite to the angle where I'm standing by? And so who would be the adjacent? The adjacent is, in case you don't know what adjacent means next to. Now, if I am standing by the red car, doesn't it have two sides next to me? It have the grass and it have what? The stone wall. So it have two adjacents. But isn't the grass already named the hypotenuse? So that means if he is the hypotenuse, then the brick wall is what? The adjacent. So, but let me turn it around now. Let's say somebody was standing by the blue car now. He was standing by this angle. The grass is still the hypotenuse. But if I am standing by the car, from his point of view, who is the opposite? Isn't his side opposite the blue car? The stone wall? And who would be adjacent? The wooden fence. So you see how opposite and adjacent can change depending on where you are standing? It's just like a room, you know. If you stand on one side of the room, one wall will be opposite you and one wall will be adjacent. But if you stand at a different place in the room, the opposite and adjacent will change. I want to do two examples for you, right? If in the second triangle, If I am standing by the orange car, I'm seeing everything from the point of view of the orange car. Isn't the stone wall opposite? And won't the fence be adjacent? It's basically like this. I'm going to tell you how I used to always do it in school. I would always figure out who is the hypotenuse first. The opposite is the next easiest person to figure out. And the remaining side will just be the adjacent. From the point of view of the golfer, if I am standing by the golfer, isn't the wooden fence opposite him from his point of view? And the stone wall would be what? Adjacent. Right? You don't need to take this down. We're going to have so much. This is just for me to help you visualize. The point is always find who first? Your hypotenuse. Next, figure out who is the adjacent. And sorry, not the adjacent. Next, figure out who is the opposite. And the remaining side will always be what? The adjacent, right? HOA. Always do it in that order. I'm not asking you if you're 100% understand, but you think we at least on 70% of understanding, at least 70%, because you're going to hear me say it 1,000,001 times as we go along. You know me, going to say it 1,000,001 times. 70% is all I ask for. So in each of these questions, we are going to try to find something missing. Before you start to draw like a mad person, right? I want you to take down these three formulas. Sine opposite is hypotenuse multiplied by sine theta. In case you all don't know what theta is, most of the times in maths, if you don't know an angle, you just call it theta, right? I'm already supposed to have a little degree sign over here. I mean, you don't have to call it theta. You could call it x, you could call it m, but most textbooks will use something called theta. The point is, there are three formulas here. I color-coded it. Red, blue, and green. One is called the sine formula, that's the red one. One is called the cosine formula, that's the blue one. And one is called the tan formula, which is the green one, okay? I'm going to show you how to use these formulas. The number one question is, there are three formulas. Can I use any one of the three at any point in time? The answer is no. For each question, you're only supposed to use one of the formulas. It takes a little bit of experience to figure out which of the three formulas to use in a particular situation. That's my job. I will show you how to do it in a little while. Take down all three formulas for me, right? And when you finish, draw only the first diagram. Only the first diagram for me. Don't draw it too small. Draw it about, I don't know, quarter of your page or 1/3 of your page. Don't need your calculators as yet, right? Now, here's the thing. In these questions, remember, a right angle triangle usually has three things: an opposite, a hypotenuse, and an adjacent. Usually, one of them will be irrelevant in the question. It's either the hypotenuse have nothing to do with the question, the adjacent have nothing, or the opposite. Obviously, if something has nothing to do with the question, you do what? You ignore it. So in this question, in our first question, they ask us to solve for x. X is the length of this side here, kind of highlighting it in yellow. So the aim of the question is to find the length of side x. Usually they will give you an angle. Which angle did they give you? The 22 degrees, that's over here. So I want everyone to pretend you are standing by this dot. That's the angle. Just letting you know, you see the right angle, you are never allowed to stand up in the right angle. The right angle is out of bounds. Don't ever, ever, ever stand there. What was the advice I gave you all? Always identify the hypotenuse first. I think we can all be in agreement. The hypotenuse is over here. It is always opposite the right angle. Everyone write in the H for me. I want you to physically write in the H. Please don't imagine it. Write it in. Now, if I am standing by the 22, which side is opposite me? The X or the 23? Remember, we are always standing by the angle they give us. If I'm standing by the dot, which side is opposite? The X or the 23? Forget about the hypotenuse. The hypotenuse on its own beat. He is never an opposite and he's never an adjacent. X will be the opposite, right? So I want you to put a little O here. So you remember this side is the opposite. And remember the advice I gave you? Once you figure out who is the hypotenuse, once you figure out who is the adjacent, opposite, the remaining side is the adjacent. So put the A by the 23 centimeters. Now remember, I told you one letter is going to be irrelevant in this question. Can we all agree that whatever we are trying to find is the most important thing in the question? I think we can all agree with that, right? So the examiner asked us to find the length of X. So guess who is the most important thing in that question? X. I think we should keep X around. Did they give us any information on the adjacent side? Yeah. Didn't they tell us the length of the adjacent side is 23 centimeters? So if they give me the length of the adjacent side, that seems like important information. Quick question. Did they give us any information on the hypotenuse? No. Do they want us to even find the hypotenuse? No. So if they don't want us to find the hypotenuse, and they give we no information on the hypotenuse, guess who is totally irrelevant and unimportant and we don't care about in this question? The H. So I want everyone to physically scratch off the H to show we don't care about him. He has nothing to do with our question and he's wasting our time. So it seems to me the only two things important in this question is opposite and adjacent. Go to your three formulas. What's the only formula with opposite and adjacent? You see how easy it is to figure out which formula you need to use? Which is the only one that has opposite and adjacent? You can call it color if you wish, or you could call it either sine, tan, or cosine. It's the green one. Look at it, the green one. I'm circling it in green too, just for showmanship. All right? Great. So we just figured out which formula to use. So everyone write the formula we plan to use. Opposite, you don't have to write OPP and ADJ. You can write it like this. Opposite, you can abbreviate it. OA multiplied by tan theta. Right? To save time now, and the examiner knows what the O means, what the A means. You don't worry about that. We okay-ish so far. Hope we okay-ish so far. Now we're not finished with the question. They want us to find what? The length of the opposite side. Whatever you want to find, write it down. So if you want to find O, write O. Everyone write O for me. Whatever you need to find, write it and put an equal sign right after. So if you want to find O, write O and put an equal sign after. Here's what you need to do now. Whatever you are trying to find, pretend it's not there or scratch it off. And whatever you are left with, that is the formula you write. So whatever you want to find, write it. Put an equal sign and scratch it off from the formula. And whatever you are left with, is what you need to type in on your calculator to get your answer. Don't worry, I have three examples lined up. You don't have to get worried. So once again, since we figured out that we needed to use the green formula, we write the green formula. According to the question, we need to find the length of the opposite side. So we write O and an equal sign. Scratch off what we want to find, and whatever we are left with in the formula, that is what we need to type in. Almost done, guys. Remember, theta represents the angle, right? What's the length of the adjacent side? What A represents the adjacent side? The length of the adjacent side is what? 23. Multiply by regular boring tan, and theta is the angle you are standing in. What's the value of the angle you are standing in? 22 degrees. Type in this straight on your calculator and you will get the answer. Type in 23, multiply by tan 22. But I can't remember the name of the person, but the person was the other calculator. Type it in backwards. Type in 22, then press tan, then press multiply by 23, right? I see a lot of people are sending me the answer in degrees, but isn't X the opposite side? A side? Your answer is supposed to be in centimeters because we are finding the length of a missing side, right? 23 multiplied by tan 22. And I am getting 9.29 centimeters to 2 decimal places. Don't worry if you didn't catch it 100%, right? Don't worry, there are plenty more examples coming your way, right? When you are finished, I want everyone to draw the second triangle. So let's see here. They gave us an angle, right? 55 degrees, right? So let me get a different color for this question. I'll use red. So first thing to do, let me just identify the hypotenuse, right? Here's the right angle. Hypotenuse always opposite the right angle. So everybody put a H by that 30 centimeters. So the 30 centimeters is the hypotenuse. Physically writing that H. Now the examiner has given us an angle. Remember, you're not allowed to stand by the 90 degrees, but he gave us a 55 degrees. This is the 55 degrees here. So we're going to pretend we're standing by the dot. Now, if we are standing by the dot, isn't the X the opposite side? So everybody put O here. So remember that is the opposite side. And like I said, the remaining side is this side, and he will always be the adjacent. Right. Tell me who is useless in this question. Is it the H, the O, or the A? One person has to be useless between the H, the O, and the A. It's definitely the A, because they want us to find the opposite side. That's why the examiner put a big X here, right? So remember, if you are trying to find X, that's the most important thing in the question. And they gave us the length of the hypotenuse, so we should keep that information. But the examiner never asked us to find the adjacent, and he even gave us no information on the adjacent. So why we even care about him? Useless, be gone, right? So we are left with H and O. Which of the three formulas has H and O in it? Is it the red, blue, or green? Only opposite and hypotenuse are involved in this question. It can't be the blue. Someone said the blue, but look again. We're looking for the one with the H and the O. To me, that's the red one. The red one has H and O. The blue one has A and H. So it could not have been the blue. It's red. Right. So now the chosen formula for this particular situation is the red. So write back, and his name is sine. So everyone write it back. O is hypotenuse multiplied by sine theta, right? So it seems, again, it just so happens in this question, we want to find the opposite side again, because x is what? The opposite. So if we want to find the opposite, write O and put an equal sign. Scratch off what we are trying to find now. If we scratch off the O, what are we left with in the formula? Hypotenuse multiplied by sine theta. Hypotenuse multiplied by sine theta. It's just a matter of putting in the values now. What's the length of the hypotenuse? Theta. Sine, and remember, theta is the angle you are standing in. And that angle looks like 55 degrees. So type in this straight on the calculator. Theta multiplied by sine 55. Press equal and your answer will be in centimeters because we are finding O, well, x, which is the length of a side. 30 multiplied by sine 55. And I'm getting 24.57. Y'all want to try the last one for me? Try the third one for me. Doesn't matter if they get it wrong. Just try your best, right? Give it a legit try. Remember, you're not allowed to use two formulas. You can't say I'm using sine and I'm using cosine. It doesn't work like that. There's only one formula per situation. So let's see what the answer could be here. Well, did everyone put x as the hypotenuse? Because x is opposite the right angle. If you get that wrong, and everything fall apart in the question, right? So whoever is opposite the right angle is the hypotenuse. The angle that we are standing up in is the 48 degrees. Who is opposite the 48 degrees? This side here. He is opposite the 48, which means by default, the 52 is the adjacent. So who is useless in this question? Well, we want to find x, who is the hypotenuse. So that hypotenuse is the most important thing in the question because we're trying to find him. They gave us the length of the adjacent, so that seems we should keep that around. It seems that the opposite is totally useless in this question. They don't want us to find opposite, and they didn't give us no information on the opposite. So why are we keeping the opposite around? What's the only formula with adjacent and hypotenuse in it? That's the blue formula. So it's the cosine formula we have to use. So let's write the formula. Adjacent divided by hypotenuse multiplied by cosine of the angle. Who are we? Oh, right. I see why some people got tricked. Who are we trying to find in this question? And the H. So I told you, whoever you're trying to find, write it down, H, and put an equal sign. That was the rules, eh? Whoever you're trying to find, write it down and put an equal sign. Scratch off now who you are trying to find. And you're left with A divided by cosine. And that is what is left in the formula. So you're left with adjacent divide. All the other ones was multiply, but this one ended up being what? Divide. Because when you scratch off the H, you're left with the A on top and the cosine underneath and a big divide sign in the middle. Okay? Don't pay attention to this multiply in this particular situation. What's the length of the adjacent side? The adjacent side seems to be 52. Cosine are made for angles. What's the angle we're starting up in? 48. Type in 52 divided by cosine 48. Right now, for the person who has the wrong side calculator, you have to type in 52 divided by, but press 48 and then cosine. So 52 divide 48 and then cosine, right? 52 divided by 48. And I'm getting 7.71 centimeters. In these three questions, you notice in all of them, we were trying to find a missing side. And that may have been obvious, right? Look at all of them. In all three questions, the examiner was asking us to find a missing side. Now, there are two major categories of trigonometry questions. It's either you're trying to find a missing side or you're trying to find a missing angle, because triangles only have two things, right? Sides and angles. I have not shown you any questions so far on how to find a missing angle. But one thing I need for you all to realize, in all of these questions, didn't you use regular boring sine, tan, and cosine? At any point, did you all have to use sine inverse, tan inverse, or cosine inverse? In other words, did you have to press the shift button or second function button? Nope. Whenever you are finding sides, to me, finding sides is the easy questions. You will always end up using regular boring sine, tan, and cosine. This is for what? When you're finding sides. Whenever you're finding angles, right? The question will force you. You'll be forced, even if you try not to use the inverse buttons, the question will force you at some point to use the sine inverse, tan inverse, and cosine inverse. But the moral of the story is this: whenever you're finding regular boring sides, it's regular boring sine, tan, and cosine you will end up using. So obviously the next set of questions is going to be what? Well, at some point, how to find a missing angle. Okay? Right. Take 10 seconds. Anything you need to take down, take it down. I'm going to move. Well, I think we do deserve a break after that, right? So let's see who is next. The first person to go was Omar, the octopus from Barbados. He is gone, right? Let's see who's next on the list. Next on the list is the fish. Who is that? Which fish? Bonzo the fish is gone. He's been turned into an ice cube. Anybody out of the game? Anybody out of the game? Omar is out and Fonzo is out by the mad scientist who has frozen them. I know a few people did choose Fonzo, so I should at least have two people out of the game by now. Two more people out of the game. We'll see who wins. All right, let's go, let's go. All right, now look at these questions. You notice where the X are in all of these questions? In all of these questions, an angle is missing. Look at it. Just draw the first question for me. Only the first one. Don't draw it too small. And the X is over here. So the aim of all of these three questions is to find a missing angle. Remember, out of the three sides, opposite, adjacent, and hypotenuse, one person will always be useless. First thing to do, Always identify the hypotenuse, no matter what. So the side opposite the right angle is over here. He is the hypotenuse. Everyone put in the H. Right? We're always standing by the angle. Now, it didn't give us the value of the angle x, but we're trying to find x, right? So the point is we have to stand by x. If we are standing by x, I think we can all agree that the 3 is opposite. And of course, by default, the 7 becomes what? The adjacent, right? So put in your H, O, and E. Who is useless in this question? It's either the H, the O, or the E. Right? Remember, X is the most important thing in this question, huh? The angle X. That's what we're trying to find. Tim Bright, and you guys are correct. The H is totally useless. At least they gave us the length of the opposite and the length of the adjacent. They give us nothing on the hypotenuse. So what are you doing here, right? Kick him out of the house, right? Great. So which formula are we going to use? What's the only formula with O and A in it? What's the only formula with O and A? Try back again. O, Angela, try back. O and A. It's the green formula. That's the only one with O and A, opposite and adjacent. So we know which one to write down. So we know which formula we're using. Opposite, adjacent, multiplied by tan theta. Everyone write down the chosen formula. Right. Now, in these questions, right, it's normal that if you're trying to find something, you replace it with the letter, right? Now, but for the time being, I just let you know, aren't we trying to find the angle over here? The aim of the question is to find the angle, right? So here's what I normally do when we're finding something, right? If we're trying to find the angle and the examiner named the angle x, instead of calling it theta, you think we could put x? It might make it a little bit easier. Everyone put x here for me, right? Because the name of the angle we're finding is x, right? Theta is just a general holder for any angle. Great. Now, when you're finding the angle, it's a little bit different. Remember, whatever you are trying to find, you write it down, right? So normally you would, normally from what I told you, you would put x, right? Because then you're trying to find x, but the x is connected to the tan. So you have to write tan x. Everyone do that for me. Since we're trying to find x and the x is connected to the tan, write tan x. Put an equal sign. If we scratch off the tan x, what will we be left with? And we will be left with opposite divided by adjacent. Look at it. When we scratch off the tan x, we're left with opposite divided by adjacent. Right. Take down up to there. Right. What's the length of the opposite side again? 3. And what's the length of the adjacent side? 7. Take 3 and divide it by 7. My advice is go properly to 2 decimal places. Take 3 and divide it by 7. I need some more space there, really. Right, so. Right. Don't put degrees. 3 divided by 7 is just 0.43. There's no degrees or anything, not yet in any case. Right? I prefer to go to 2 decimal places. But are we finished with the question? The last time I checked, right? We were trying to find the value of x. Remember at the beginning of class today, I told you that if you have a situation like this and you want to solve for x alone and you need to throw across the tan, so I'm going to continue the working up here, right? So when you throw across the tan, the opposite of tan, remember if you throw across the tan, the x degrees will be left on this side. The opposite of tan is tan inverse. And who is waiting for him? 0.43. Now you're finished with the question. Type in tan inverse 0.43. You see how the question forced you to throw across the tan at the end of the question? Because remember, you want to solve for x. So press your second function button or shift button to get the inverse of tan and then press 0.43. Second function tan, 0.43. I am getting, now you get to put your degrees, 23.27 degrees. Now you get, because x is a degree, right? X is an angle. So your final answer has to be in degrees. When you're finding an angle, it's be a little bit more work. But don't worry, we have 2 more questions to practice, right? So you all can build some confidence. Take a 20 seconds, take down what you need to, and we're going to try B. But draw the second diagram one time. Draw B for me, please. All right, so, okay, guys, I can't give too much more time. Use a different color. All right, so in this question here, they're asking us to find what? The angle x. First thing to do, let me just get to who is the hypotenuse. Opposite the right angle is the hypotenuse. So this 15 is the hypotenuse. We're standing by x. 7 is the opposite based on x's position. And of course, the remaining side is the adjacent. Who useless in this question? Who has no purpose in this question? Right? And the answer is E. So you can lightly scratch off the A if you wish. And at least tell me who is the correct formula. Only H and O remain in the question. Red, blue, or green. Sine, cosine, or tan. Let me at least get that. Right? Great. So I'm going to give you all a couple of minutes to see if you can do the question. I know not everyone is going to get it correct. That is okay. Just try. So use the red formula and produce an answer. Right or wrong, send the answer on the chat. See. So we said it's the red formula. So it's opposite hypotenuse multiplied by sine theta. Right now, the name of the angle is x, right? So it don't matter if you put x or theta here, right? Since we're trying to find the angle, we put what? We're trying to find x. We just can't write x because the x is connected to the sine, right? So we put sine x. Scratch off the sine x. What are we left with? Opposite divided by hypotenuse. Opposite divided by hypotenuse. What's the length of the opposite side? Seems to be 7. What's the length of the hypotenuse? Seems to be 15. So we get sine x degrees. Let's divide 7 by 15. Now go to 2 decimal places. And I'm getting 0.47. Some people divide it wrong. They say 15 divided by 7. 7 divided by 15 is 0.47. Check it back, right? You have to press the 7 first, then divide by 15, right? You're typing in wrong. I don't know why some people just type it in wrong side by mistake. Now remember, the aim of the question is to solve for x. So that means we're going to have to throw across the sine, right? When you throw across the sine, you're going to get what? Sine inverse 0.47. So second function, sine. There's some people said I have it wrong, 7 divided by 15. Anybody disagrees with what I said with the 0.47? I'm getting 0.47. I'm pretty sure it's 0.47. Right. Yeah, that's correct. I don't know why people would say it's something else, right? Right. So anyway, let's go ahead. Second function, it's just a matter of typing in properly on the calculator. Second function sine 0.47 is 28.03 degrees. Make sure you physically see that on your calculator. All right, let's see who is next to go. Let's see who is next. Oh no, a lot of people are out of the game. It's Shaka the Shark. He is out. Okay, let's move on. All right, so draw this diagram here, right? And so, sometimes I might teach you something in class, right? And I tell you, hey, find this, find that. I mean, okay in class and whatnot, right? But then when the exam comes, it is worded different. And you're like, what? I don't understand what the examiner is saying. Sir said it so clearly in class. And now the examiner phrased it in such a manner, same type of question. It's just his wording is crazy, right? And I think everyone has been a victim of that, right? This question. The examiner wants you to find an angle, but it seems like he didn't specify it too well here, right? He said find angle BAC. Whenever they give you 3 letters, right? It's always the middle letter. Always the middle letter. I know you all are saying, why do they have to make things so difficult? Why did they just go and say find angle A, right? So it's this angle they want you to find. Y'all want to take a shot at it, right? Pretend you're standing in angle A. And you can call the angle A. Instead of calling it X, well, the angle has an official name, A. Let's pinpoint who is the hypotenuse. The side opposite the right angle is always the hypotenuse. If we're standing at A, because remember, we're trying to find angle A, so pretend you're living inside that angle. The 12 would be opposite. And of course, CA would be what? He's the remaining side. He is the adjacent. Okay? Who is useless? The opposite, the adjacent, or the hypotenuse? Who is useless? To me, it's the adjacent, right? Because they gave us information on the opposite. They gave us information on the hypotenuse. But the adjacent, well, he had nothing to do with that question. So yes, guys, you are correct. Well, the majority of you are correct. If you got it wrong, still thanks for trying. We're using the red formula. And instead of putting theta as the angle, we have an official name for the angle, A, right? So since we're trying to find sine A, right? Well, A, you put sine A. Scratch off that, right? What we're left with? Opposite divided by hypotenuse. What's the length of the opposite side? The opposite side is 12. Look at it here. 12. And the hypotenuse is 13. I'm going to assume that most people have up to there, right? So sine A is 12 over 13, right? That's by equal sign here. So let's divide it here. I think you're going to get a crazy decimal. And remember in this class, we said it over and over. We always go to how much decimal places? 2. And we do it properly, right? So we're going to get 0.92. Think that's correct? Now remember, we have sine A is equal to 0.92. Now, last time I checked, we're trying to solve for what? A. So you throw across the sign, and remember in maths, when you throw something across, we always get the opposite. So when you throw across that sign, because you want A alone, you want angle A on one side by itself, you're going to get the opposite. Sine inverse 0.92. And it's just a matter of typing in that on your calculator. Since it's the inverse, you press second function and sign, or shift and sign. Second function, in my calculator, second function, 0.92. And we're going to get 66.93 properly to 2 decimal places, right? Levi, I sent you a message on the chat. Do you mind replying? Levi Clark, could you just respond to me quickly, please? All right, guys, so let's go back and do that question. We did not do C, so I'm going to give you all a chance now. Find angle X. Well, somebody has the answer already. All right. Right. So if you're standing by X, right? Well, first of all, the hypotenuse is the 10. This side is the opposite, and the 8 will be the adjacent. So I think we realize the opposite have nothing to do with this question because they gave us information on the hypotenuse and adjacent. So you need the one with H and A in it. That's cosine. So we're going to write down the formula here. I'll use blue, right? So adjacent over hypotenuse multiplied by cosine theta. So you want to find, well, the name of the angle is X. So let's put X for the angle. We want to find X. So we put cosine X, right? If we're trying to find cosine X, we scratch this off. We're left with adjacent over hypotenuse. So the length of the adjacent is 8, and the length of the hypotenuse is 10. So when you divide it, you get 0.8. But so many people stop the question there like it's correct. But I thought the aim of the question was to solve for angle X, not cosine X. I remember for every single question we didn't find in angles, we had to get rid of the cosine now. We throw across the cosine because we want X alone on one side. That's what we're solving for. Throw across cosine, you're going to get cos inverse 0.8. Okay? Second function, cosine 0.8. And now we get 36.87. Right.